Nobody wants to deal with a nuclear war, and it looks like the world is already done with dealing with any of these anymore. But electromagnetic pulse from detonations can still create some serious problems, and you will be totally unaware of what's happening. Nuclear weapons are by far the most dangerous weapons on the Earth. One weapon alone can destroy an entire city, potentially killing millions of people while also jeopardizing the natural environment and lives of future generations through its long-term catastrophic effects. With all the political tensions that we have combined with the evolution of technology, the way we use nuclear weapons will also change. So how dangerous is a nuclear electromagnetic pulse? Will it affect the gadgets that we use or the power grid? Well, keep watching till the end of the video to know a lot more about the effects of nuclear electromagnetic pulse, including the power grid. The development of electromagnetic pulse is shaped by the initial nuclear radiation from the explosion, very specifically the gamma radiation. Higher energy electrons are produced in the environment of the explosion. When the gamma rays collide with the air molecules, a process known as the Compton effect. Both positive and negative charges in the atmosphere are separated as the lighter negatively charged electrons are swept away from the explosion point and the heavier positively charged ionized air molecules are left behind. This charge separation produces a large electric field. The characteristic of the electromagnetic pulse will also strongly depend on the height of the explosion above the surface. EMP was first noticed in the United States during the 1950s, when electronic equipment failed because of induced currents and voltages during some nuclear tests. The potential vulnerability of the U.S. military equipment and weapons systems to EMP was sufficiently recognized only in 1960. EMP will damage unprotected electronic equipment such as televisions, telephones, computers, radios, and other radars and other communication equipment. These damages can occur at distances of tens or hundreds or thousands of kilometers away from the nuclear explosion, depending on the type of weapon used and the altitude of the detonation. For example, in 1962, a failure of the electronic components in streetlights in Hawaii and the activation of numerous automobile burglar alarms in Honolulu were attributed to a high-altitude U.S. nuclear test at Johnson Atoll, which is about 800 miles or 1,300 kilometers to the southwest. To understand the impact of nuclear electromagnetic pulse, you need to know what exactly it is and how it is created. An electromagnetic radiation burst produced by a nuclear explosion is known as a nuclear electromagnetic pulse or nuclear EMP. Damaging current and voltage surges could be produced by the consequent quickly varying electric and magnetic fields when they interact with electrical and electronic equipment. The detonation's height is one of many variables that affect a nuclear EMP event's distinct features, and it is also the most significant one. The most important mechanism for electromagnetic pulse or EMP production from a nuclear detonation is the ionization of air molecules by gamma rays that are generated from the explosion. These gamma rays ionize the air molecules by interacting with the air molecules to produce positive ions and recoil electrons known as Compton electrons. This pulse of energy, which produces a powerful magnetic field within the vicinity of the weapon burst, is called electromagnetic pulse. Electromagnetic pulse can also be produced from non-nuclear sources like electromagnetic bombs or E-bombs. Higher altitude nuclear detonations and electromagnetic bombs can also generate an electromagnetic pulse that has the potential to damage or even destroy your favorite electronic devices over widespread areas. The electric power systems would also be at risk from surges produced by such weapons. The good news is that the EMP from a kiloton range surface nuclear explosion would not produce serious damage outside the radius of severe destruction from the blast. Most of the unprotected electronics in the entire continental United States would be destroyed by a 1.4 megaton bomb dropped roughly 250 miles above Kansas. A 1.4 megaton nuclear device was exploded above Johnston Island in 1962 during the brief reintroduction to atmospheric testing at a height of around 250 miles. 800 miles to the east of the explosion in Hawaii, people saw the effects of the EMP. On Oahu, streetlights and fuses failed and telephone service was interrupted on Kauai Island. A nuclear electromagnetic pulse consists of three components. According to the International Electrotechnical Commission, they are called E1, E2, and E3. The E1 pulse is a very fast component of the nuclear EMP. It's a brief but intense electromagnetic field that induces high voltage in electrical conductors. It also causes more damage by causing electrical breakdown voltages to exceed. It can also destroy your computers and communication equipment. The worst part is it acts really quickly for ordinary surge protectors to provide enough protection from the nuclear electromagnetic pulse. Then you have the E2 component, which is generated by scattered gamma rays and an elastic gammas produced by neutrons. This E2 component is an intermediate time pulse that lasts from about 1 microsecond to 1 second after the explosion. It is also very similar to lightning, even though the lightning-induced E2 may be considerably larger than a nuclear E2. But because of its similarities and the widespread use of lightning protection technology, you could easily protect ourselves from E2. Then you have E3, which is quite different from E1 and E2. because this is a much slower pulse lasting tens to hundreds of seconds. It's caused by nuclear detonation's temporary distortion of the Earth's magnetic field. E3 can produce geomagnetically induced currents just like a geomagnetic storm in long electrical conductors, damaging components such as power and transformers. EMP is not radioactive and it has no known effect on living organisms, but it does have the ability to temporarily or permanently disable electrical and electronic equipment. When detonated, an EMP weapon will produce a pulse of energy that creates a very powerful electromagnetic field that is capable of short-circuiting a wide range of electronic equipment, including satellites, radios, computers, radar receivers, and even the traffic lights. If that happens, things will go out of control because all of our communication facilities would be compromised. If there are no traffic signals, it will lead to a total chaos with so many deaths. Because of the fact that EMP is electromagnetic energy traveling at the speed of light, all of the vulnerable electronic equipment in the detonation zone could be affected simultaneously. This is something that we need to take seriously because we live in a day and age where we are completely dependent on electronic systems that work with components that are very susceptible to excessive electric currents and voltages. Most of our electronic systems are controlled by semiconductors, and these devices fail when they encounter an EMP because of the local heating. Failure of semiconductor chips could also destroy industrial processes, power and phone systems, railway networks, and even access to water supplies. Commercial computing equipment is also extremely vulnerable to the effects of EMP. Computers that are used in communication systems displays, industrial controls, data processing systems, road and rail signaling, and those military equipment which includes electronic flight controls, signal processors, and digital engine control systems will be vulnerable to the effect of EMP. Telecommunication equipment is also highly vulnerable, and receivers of all varieties are particularly sensitive to EMP, which means all the radar and electronic warfare equipment is vulnerable to the effect of EMP. If you drive a modern vehicle, you are out of luck because they are equipped with electronic ignition systems, which are also vulnerable. Luckily, the materials underground are partially shielded by the ground, but they are still collectors, and these collectors deliver the EMP energy to some larger facility. This produces surges that can destroy the connected device, such as power generators or long-distance telephone communication systems. So what can we do to protect our electronics? Well, the two basic ways to protect against the effects of EMP. The first one is called metallic shielding, where shields are made up of continuous pieces of metal such as steel or copper. A metal enclosure generally does not fully shield the interior because of the small holes that are likely to exist, which means this type of shielding will be equipped with additional elements to create a barrier. Commonly, only a fraction of a millimeter of material metal is needed to supply adequate protection, and the shield must completely surround the item to be hardened. The second method is Taylor hardening, which is a much more cost-effective way of hardening. In this method, only the most vulnerable elements and circuits are redesigned to be more rugged. The rugged elements will be able to withstand much higher currents. On the other hand, this method has also shown several unpredictable failures in testing, so this method might only be useful in making the existing systems less vulnerable. The non-lethal nature of electromagnetic weapons makes their use far less politically damaging than those conventional weapons of choice, therefore broadens the range of military options available. EMP-producing sources other than nuclear detonation have been successfully developed with several countries, including the United States, already working on non-nuclear bombs that are capable of generating electromagnetic pulses. Electromagnetic bombs are also specialized non-nuclear tools designed to destroy information systems. These devices will be used in battlefield applications, and their effects would be restricted to a very small area. High-power electromagnetic pulse generation techniques and high-power microwave technology have already advanced to a point where practical electromagnetic bombs are becoming technically feasible, with new applications both in strategic and tactical information warfare. EMP shockwave can be produced by a device small enough to fit in a briefcase. All of this is classified information, but it's believed that the current efforts are based on high-temperature superconductors to create intense magnetic fields. The development of conventional E-bomb devices will result in the use of these weapons in nuclear confrontation to defeat an enemy without causing loss of life. Most of the defense systems rely on satellites and commercial computer equipment to communicate, so the effect of EMP on military equipment will result in irreversible damage to a wide range of electrical and electronic equipment, especially radios or radio receivers and computers used by the military. Regardless of all those, experts agree that electromagnetic pulse can be powerful enough to cripple electric wiring and circuitry over a large geographic area, which means it can pose a real threat to any country's critical infrastructure.